All right, good morning, and hope you guys are having a good e-learning day so far. Today we are going to go over our notes for 9.2. Not a whole lot of new stuff from yesterday, just a few little things and then a little bit more practice interpreting graphs. So if you were in class yesterday, you should have a paper copy. At the high school, if you were in class yesterday, you should have a paper copy of the 9.2 notes. If you were at the middle school or you were absent or you're virtual, then you don't have a printed out copy of this, so just go ahead and in your lined notebook paper, pause this, sketch the graph, and then you'll have to pause it every so often and kind of jot down some of the questions that we're asking. So it might take you just a few extra minutes. I apologize for that. So we are going to look at example 1 here. And again, the first thing you always want to look at when you're interpreting a graph is the graph's name and then the name of the two axes. So this is Drew's bike ride, and the x-axis running along the bottom is time in minutes, and you want to watch that. It's not hours here, it's minutes, so that makes a difference. And then along the y-axis is distance from home. So that tells you that Drew's bike ride started at home, so at the origin point, or at 0, 0, which is right here. Okay, at 0, 0, he's home, okay? And the title doesn't tell us where he's going, so we need to keep that in mind when we're answering some of these questions. All right, so we've kind of already answered this, but where is Drew at point A? Well, point A is that origin point at 0, 0. And because the name of the y-axis is distance from home, we know that at that beginning point, Drew is at home. So where is Drew at point A? He is at home. Okay, and then it says, what is another name for point A? And this is something new that we are going to talk about today that we did not talk about yesterday. So if we look along the x-axis, we can see that every 2 spots is worth 10, and we know that that origin spot is 0. So we've got 0, and then we've got 2 more dashes later, 10, 20, 30, 40, 50, 60, okay? So if we needed to, right, we know that this would be 15, this would be 25. So you can kind of fill in the gaps if you need to. We don't necessarily need to here, but just so you know that you can do that. And so we want to know, what is another name for point A? Well, point A is right here at 0, right? And because this axis is called time, we can call this t equals 0. So another name for point A is t equals 0, okay? And so this will come in handy here in a little bit when we start seeing some of this t equals in our questions. All right, so what is the rate between point A and point B? Okay, point A to point B. And so today's takes a little bit more math when you're talking about minutes, because when you're talking about something in hours, it's really easy to figure the miles per hour. And we did that in yesterday's video and in class yesterday. So if you go 40 miles in 1 hour, you're going 40 miles per hour. So it's pretty easy to find the per hour. If everything's in minutes, you have to do a little bit of conversion in order to still figure the miles per hour, because remember, rate is always, when you're talking about distance over time, it's always miles an hour, right? So if you've got distance over time, right? And when we were doing it yesterday, if we went 40 miles in 1 hour, you could write that as 40 miles per hour, right? 40 miles in 1 hour, or 40 miles per hour. Well, we also have to remember that an hour can equal 60 minutes, right? So an hour is the same as 60 minutes. So we're going to kind of keep that in the back of our head here in a second. All right, so what is the rate between points A and points B? Well, first of all, let's look at the distance covered, because we want distance on top. Let's look at the distance covered from point A to point B. So point A is here at 0 miles from home, and point B is up here at 2 miles from home. So the top of your equation, or of your fraction, is 2, right? Because he went 2 miles. And then let's look at our bottom. Well, our bottom is in minutes. And so first of all, let's look at how much time elapsed from point A to point B. So you've got from 0, oops, there we go. You've got from 0 to point B right here is 20. So it's 20 minutes, okay, 20 minutes. But that's not a rate of miles per hour. And so we need to convert this to miles per hour. So the way we do that is we need the bottom to be 60 minutes, right? Because we need the bottom to be 1 hour. And so if we want the bottom to be 60 minutes, what did we have to multiply this by to get 60? Well, to get 60 from 20, you have to multiply it by a 3, right? And the rule in math is if you do it to the top, you do it to the bottom. So we also have to multiply this times 3. And 3 times 2 is 6 miles. And so you would write this, right? 6 miles in 60 minutes. And we know that 60 minutes is also 1 hour. So if you go 6 miles in 1 hour, that is 6 miles per hour. Okay? So the answer to number 2 is 6 miles per hour. Okay? And again, right, you got to really watch it when your graph is given to you in minutes. You have to convert that to hours. Okay? All right, so next we have what is going on between point B and C. Well, let's look at B and C. So if we look at the distance between point B and C, at point B we're at 2, and at point C we're also at 2. So our distance did not change, and our time between B and C is between 20 minutes and 30 minutes. So the answer to number 3, what is going on between points B and C, is that Drew is stopped, right? That covers the distance for 10 minutes. Because remember, when you describe what's going on in a segment, you have to describe the y-axis and the x-axis. So the y-axis information is that he stopped. He didn't travel any distance, right? From 2 miles from home to 2 miles from home, he didn't go anywhere. And then along the x-axis, how long did that just B to C last? It lasted for 10 minutes. So that would be the answer for number 3, is he stopped for 10 minutes. Now it wants to know, where is Drew at t equals 30? Okay, so where is Drew at t equals 30? Well, again, you got to remember another way to, along the bottom, write that t right here. This is t equals 30, all right? T equals 30 is the timeline at 30. Well, where is Drew at here? So we have to follow our 30 up, and he is where? Well, if we follow our blue line across, right, where is he at that 30-minute mark? He is 2 miles from where, though? It's really important to put from where, right? Because 2 miles from the grocery store, 2 miles from his school, 2 miles from where? You have to be specific. So at t equals 30, he is 2 miles from home. Because from home, right, comes right here. That's the only reference point we have here. We don't know where he's going. We just know where he's coming from. So our reference point needs to be always from home. All right, what is another way to label t equals 30, right? Well, t equals 30, we could label as, and I got to erase this because I've kind of, there we go. T equals 30 is point C. So another way to label t equals 30 would be point C. Because at t equals 30, again, you go straight up and you get that C mark, okay? All right, so how long has Drew been on his bike ride at t equals 40? Well, that's kind of, you don't even have to do any math here. Let me erase this t equals 30 here just to get it out of the way. How long has Drew been on his bike at t equals 40? Well, time equals 40, and we know from the graph label that time here is in minutes. So he has been on his bike ride for 40 minutes. Because time equals 40. 40 what, right? 40 minutes, 40 seconds, 40 hours, and in this case it tells us right here that it is 40 minutes. All right, so what is happening between T30 and T40? Okay, so that's just like saying what is happening between C and D. Because, let's erase everything we've done so far just to kind of give us a clean slate here. Okay, so we want to know what is happening between, what is happening between T30 and T40? Well, here's T30 right here. So that's the point C. And T40 is right here, and that's the point D. So another way that you could read that is what's happening in the segment CD, or what is happening between CD, or what's happening between T30 and T40. It all means the same thing. So first let's look at distance. So the distance traveled between C and D, right? That's the segment we're looking at. C to D. And that distance, that's right here, that is a 2-mile distance. So in that segment, okay, we went 2 miles. Okay, that's the top because distance is on top. When you're calculating a speed, it's 40 miles per hour, 40 miles on top, 1 hour on bottom. All right, so we got our distance of 2 miles on top, and then the time that it took is right here, right? We already kind of drew that in there, that 30 to 40. So we know that that took 10 minutes. Okay, 10 minutes. But we also know that we need to write our speed in terms of hours. So on the bottom, we know we need 60 minutes, right? Because that is an hour. So on the bottom, we've got 60 minutes because we know that that's 1 hour and we need 1 hour on the bottom. What do we need to do to the 10 to get it to equal 60? Well, we need to multiply it by 6. And if we do that to the top, we do it to the, or if we do it to the bottom, we do it to the top. So 6 times 2 is 12 miles. So we could write this as 12 miles per hour. And that is your answer to what is going on between T30 and T40 as that Drew is riding his bike at 12 miles per hour. Okay? All right, so why do segments CD, so let's kind of color code here what we're looking at here. So let's erase this. All right, so it says, why do segments CD, so here is CD, all right, oops. Segment CD, right, that's there. And segment DE have different slopes. Well, here is segment DE. We talked about this yesterday. What does the slope mean, right? So if you can see here that CD is kind of a really steep slope and DE is not as steep of a slope. Well, what does that mean, or what does that indicate, right? It means their speeds are different. So the segment CD and DE, why do they have different slopes? Because, and there we go, Drew is traveling at different speeds or rates of speed, right? At different speeds. And you can also think that as a rate of speed. Okay, basically miles per hour. So the slope is going to be different when the rate is different. And so when the rate or the speed is steeper, he's going faster. So if you were to have to say what segment between CD and DE is Drew traveling the fastest, the answer would be CD, because that CD segment is a much steeper slope than the DE segment. And so he's going fastest here, or faster here than he is here. Okay? All right, it says, what is the rate between points D and E? So points D and E here are that pink segment. And so let's look at what's going on here. So first, let's look at the distance traveled between D and E. So D and E, D and E is between 4 and 5 in the distance. So only 1 mile, right? 1 mile is being traveled. So that takes care of the y-axis. And remember, when you're describing what's happening, or when you have to calculate the rate, you need both the distance and the time. And then our time between D and E is between 40, all right, between 40 and between 60. And just that spot right there is 20 minutes. So we have 20 minutes. And again, with rate, you always want to do it miles per hour. So we know that 60 minutes is an hour. So that's going to put hour on bottom. And again, what did we have to do to 20 to make it equal 60? Well, if we multiply 20 by 3, we get 60. And if we do it to the bottom, we have to do it to the top. So I'm also going to multiply the top by 3. So I get 3 miles. And 60 minutes is the same as 1 hour, so that means that in segments, or between the points DE, Drew's going 3 miles per hour. And that would be the answer to that one. All right, so how far away from home is Drew at the end of his ride? Okay, so we want to look at the end of his ride, which we can see here is point E. And we want to know how far from home is he at this point. Well, we just have to look at the distance, right? At point E, the distance is 5. So he is 5 miles from home. Okay, that's the answer to that, 5 miles. How long did it take Drew to get 3.5 miles from home? So first, let's find 3.5 miles from home. Well, if here's 3 and here's 4, then that makes this 3.5, right? And so if we follow 3.5 all the way over, then we're going to go straight down from that point. And this doesn't land right on one of our grid lines, and that's okay. We can still get a pretty good estimate here. So let's think about what this means. We've got 30, 35, and 40, right? And that red line comes down between 35 and 40, just a hair closer to 35. So I would say that that's probably 37. So the answer to number 11, how long did it take Drew to get 3.5 miles from home? And the answer to that would be 37. And then 37 what? Well, that's 37 how long? That's a time question, so 37 minutes. Okay? And then the last question is, how long was the whole bike ride? Well, that just requires us to go to the end point, which is E, and come straight down to the time of 60, right? And so how long was the whole bike ride? It was 60 minutes, right? And you could also say 1 hour. Either one of those would be fine, okay? So when your units is in minutes, you got to do a little calculation to get it to miles per hour. And then the other new thing here is when you're along the bottom, you could call this, right, if we were going to name these, this could be T equals 20, this would be T equals 50, this one would be T equals 60, so it's just time equals, time equals, time equals, okay? All right, let's do one more example, and we don't have near as many questions on this one. So, but I want you to notice something. This one is a little different, and it means that the lines, the flat spots and the ups and the downs, they mean something totally different. So, the first thing I want to note that this is Colin's drive to work, okay? So we know that we don't know where he started from, but this is his drive to work. And then we also want to note that the y-axis here is not distance, okay? And this is going to matter a lot in how you answer your questions. It is speed, okay? This is his speed in miles per hour. So if you look along here, you've got 5 miles an hour, 10 miles an hour, 15 miles an hour, 20 miles an hour, so on, all the way up to 50 miles an hour, okay? That is his speed. And then along the bottom is time in minutes. And just really quickly, I want to make note right down here that velocity and speed are interchangeable, or they mean the same thing. So if you find a graph that says anything about the velocity, of something. It just wants to know the speed, and we know that we write velocity and speed in miles per hour. Okay, so if you see velocity, your answer is still going to be in miles per hour. Okay? All right, so what is happening between points A and points B? All right, so this is where it's different, because when we're talking distance graphs, a flat spot means they didn't go anywhere, right? Because if a flat spot means your distance was 2 miles and then 2 miles, that means you didn't go any miles. When it's speed over here, okay, it's way different. So what is happening between points A and points B? Well, between A and B, right, which is here and here, the driver maintained 40 miles an hour, right? So he maintained a speed. Oh, he had his cruise control set, right? Maintained 40 miles per hour, and that's just the y-axis, right? That just tells us what's happened along the y-axis. So we also know to know for how long. So well, that means we need to look at from the segment A to B in our time. So A to B is 15 minutes. So for 15 minutes. Okay? So from spot A to spot B, Colin has cruise control set, and he stayed right at 40 miles per hour for 15 solid minutes, right? Didn't hit the brake, didn't accelerate, just stayed going steady at 40 miles an hour, okay? So that is not, when it is speed on the left, a flat line does not mean stop. So you really have to watch. Remember when I said yesterday, you really have to watch your axis labels because they change what the graph means, okay? And this is a good example. All right, so now we want to know what is happening between T15 and T20. Got a little happy and started to skip one. All right, so first let's look. So T15, that's here. Okay, T15, that is here. And T20 is here. So we just want to know the segment BC, right? So we're going to look here to here. So just that segment, right? From T15 to T20, we need to follow that up and see what points those are. That is the points BC. And so if you look at the y-axis, what happened between BC? Okay, Colin sped up, right? He went from going 40 miles an hour to 50 miles an hour. So you can say that he sped up by 10 miles an hour, or he sped up to 50 miles an hour, or he increased his speed by 10 miles per hour. All of those are really acceptable. So he increased speed by 10 miles per hour. How long did it take him to increase that speed, right? He gradually increased his speed over from 15 to 20. That's 5 minutes. So increase speed by 10 miles an hour in 5 minutes, or over 5 minutes, however you want to word it. But we've got the description of what happened on the y-axis, which was that there was a 10 mile an hour increase, and we have the description of the x-axis of that it took 5 minutes to do that. All right, do the same thing here, but now we're going to look at T20 to T25. So let's erase that. So let's look and see where T20 is. So T20 is right here. So T20 is here. That's our C. And T25, that's our D. So if you want to look at the other axis, that's that 50 mile an hour, right? For C and D. It didn't change. Well, remember again, right? When speed is what we're talking about, 50 mile an hour speed from C to D. So again, he maintained 50 miles per hour, right? He set his cruise control. He maintained 50 miles an hour for how long? Well, 20 to 25 is 5 minutes. Okay, he set his cruise control and he stayed at the same speed, 50 miles an hour for 5 minutes. All right, what is happening between points D and E? So let's look here. Erase that. All right, so between points D and E, we already have D marked. Well, let's mark E. Okay, mark E. And then we also want to mark what's happening over here. So he was going 50 miles an hour at point D, and then he slowed down to E, which is 25 miles an hour. So what happened here? Well, he decreased, right? Or he slowed down. He decreased by, well, how much did he decrease? He went from 50 down to 25. So he decreased by 25 miles per hour. In how long did it take him to do that? He just gradually slowed down, and he did that over 10 minutes. Right? Because from D to E on the time spot is 10 minutes. All right, how long does it take Colin to get to work? And this is where the graph it's not really realistic because, right, the last thing we know about the graph, right, was that Colin was going 25 miles an hour, right? That's our last known bit of information right here. He was going 25 miles an hour. So I guess we're just going to assume that Colin just screeched to a dead halt and just stopped, right? So that's all we can assume because we don't really have what would have happened is he would have gradually slowed down from 25 to 0 over a minute or so. But we don't have that information on the graph, so we just have to go with what we have. So he was going 25 miles an hour, right? He pulled into his parking spot really, really fast and then just stopped immediately. So we're going to assume that's the end of our graph. So how long does it take for Colin to get to work? It's right here. It's 35 minutes. And how long does Colin maintain a 40 mile an hour speed? All right, so maintain in speed means a flat line. And here's our 40 mark right here. So that's the spot where he maintained 40 miles an hour. And he did that for, how long did he do that? He did it from here to here. So he did that for 15 minutes. And is Colin ever stopped? If so, where? Okay, and again, this is where you really have to remember that these flat spots here, right? We had a flat spot here and a flat spot here. Flat spots when you're talking speed does not mean stopped like it does in the earlier graphs when we're talking distance, right? So, is Colin ever stopped? If so, where? Well, we can assume, right, because he went to work. Is he ever stopped? I would say yes, at work. Okay, that would be the only time in our graph that he stops because he does not stop here, right? He maintains 40 miles an hour. He drives faster for a bit. Then he sets his cruise again and he maintains a speed of 50 miles an hour in C to D. Then he slows down as he gets closer to work. And then if we're assuming point E is at work, then we're going to assume that right there at point E, that's when he stops. And he stops when he is at work because we know that it is his drive to work. Okay? So it's just a matter of deciphering the graph, figuring out what it means, pulling apart what the y-axis and the x-axis actually mean. And again, be really careful, right? Flat spots in speed mean maintaining. So flat equals maintaining a speed. Maintaining speed when you're talking speed, but here, right, this flat spot, because this is distance, no distance was traveled, so a flat spot equals stopping when you're talking distance. Okay, so don't just assume since you see a flat spot that it's stop or that it's speed or maintaining. It depends on your graph and what everything is labeled. All right, that's all I've got for you. Email me if you have any questions. Work on the 9.2 homework assignment. It is due tomorrow at the beginning of class for in-class students and at 4 p.m. for virtual students. And if you're quarantined or absent, you can follow along and stay caught up by doing the online assignments, taking your notes in your 3-ring binder, and then clicking on the Kami load button and finishing your assignments in Kami. Okay? So let me know if you have any questions, and I will see you in class tomorrow. And virtual students, if you need anything, we can always jump on a video call. Have a great day.